Okay, so the type of function I will be doing today is an absolute value function. Absolute value functions usually are a V-shaped looking function. The V shape could also go downwards, but it only goes downwards when the A value, which in this case would be the 2, is negative. If the A value is a negative number, then your absolute value function would curve upside down like this. But since today it is a positive, the A is positive, the function would go upward. So our function says f of x is equal to 2 in absolute value x plus 4 minus 3. Okay, so what I would like to do first is I usually like to find my vertex first. For my vertex, I usually see what value in the absolute value bars can I make this 0. So the value I would put in is negative 4 as the x. So I would write that down, negative 4. So I would do negative 4 plus 4, which is 0, times 2, which is also 0, minus 3, which would be negative 3. So my vertex would be negative 4, negative 3. And I'll plot that down. And then the next thing I would do is I try to find the point that is closest to my vertex. So let's do negative 3. So negative 3 plus 4 is negative 1, but since this equation is an absolute value, it'd be positive 1 times 2, which is 2, minus 3, which would be negative 1. So then I would plot negative 3, 1. As you can see now, there is a pattern that you would go over 1 and then rise 2. So what I would do is I would plot the rest of the points that could fit on this graph. So I just continue to go over 1 and rise 2. And then since I plotted all the points to the right of going over 1 and rising 2, now I would go to left 1 and over 2 from the vertex. Okay, now since I have all these points plotted, I would try to connect my line the best I could, the straightest I could to be precise. Since absolute value functions have straight lines, you would try to make your line straight as possible. I would advise to use a ruler. And now, since these are just a few points that I could plot, technically the graph could go bigger and bigger, but since this is as big as the graph gets, I would put arrows at the end of each line to emphasize that they could go on forever. Okay, since my graph is down, I would try to fill in all the rest of these. So first, let's see the domain. The domain is usually the value on x and see how far it would go on the x-axis. So since on the x-axis we have 0, we have an arrow at the end. And then that emphasizes that it can go infinitely to the left or to the right. We would say in these brackets, x, and then this symbol means as long as. So x is x as long as x is equal to all real numbers, since it can go infinitely to the left or to the right. For the f of x, which we would say is the y-axis, you see it goes up from -3 up. So your range would be in the brackets again. Here, let me make the brackets better. In the brackets, and since we use f of x into the equation, you should make your range, whatever value it is, the same value as you have for your equation. So you would say f of x is f of x as long as f of x is greater than or equal to, since it touches -3. -3. Okay, next you would try to find is the symmetry. The symmetry is when it cuts evenly in, like on your function, it would cut evenly. So that point right here, you can tell it cuts evenly since it's kind of a reflected image. So you would want to draw your line of symmetry throughout the graph. And then, as you can see, the line of symmetry is on the x-axis. So what your symmetry would be is x is equal to -4. It would be -4 because, as you can see right here on the x-axis at -4, that's where your line of symmetry crosses through. So the asymptote is where a line would try to reach a certain point, but it never actually does. It just becomes a smaller and smaller decimal that's trying to reach the number but never actually occurs. But since all these numbers, they actually touch a point, there would be no asymptote. Okay, next is for the y-intercept. For the y-intercept, it's where your line cuts on the y-axis, or where it crosses over the y-axis. As you can see, it crosses over the point. You would usually want to write your intercepts in coordinate form. So you can see it is 0, +5. So what your y-intercept would be 0, 5. Okay, and then you're trying to find the x-intercept. Now the x-intercept can be a little tricky because there would technically be 2, and since you can't really tell what it is, you would actually have to calculate this one. In order to find the x-intercept, what you would do is say 0 is equal to whatever equation you have. So in this case, it would be 0 is equal to 2 absolute value x plus 4 into absolute value minus 3. So you would try to solve everything besides the absolute value. So what you would do is plus 3 on each side. 3 is equal to 2x plus 4 minus 3. So what you would do, you wouldn't add the 3, my mistake, sorry. Then you would divide by 2 on each side, and then you get 1.5 is equal to x plus 4 in the absolute value bars. This is the point where you would split your equation up like so. So 1.5 is equal to x plus 4. And since you're trying to find the opposite of that, you would get negative 1.5 is equal to x plus 4. Let's write this so we can fit it. So it'd be negative 1.5 is equal to x plus 4. So you would subtract 4 on each side. That will leave you, for one side, negative 2.5 is equal to x, and on the other side, it would be negative 5.5 is equal to x. And as you can see on the graph, that fits perfectly. See, negative 2.5, negative 5.5, that looks perfect. So, for your x-intercept, it would be negative 2.5, 0, since it's 0 on the x-axis. Then it would be negative 5.5, 0, again on the x-axis. So now we will find the end behavior. End behavior is usually telling you, like explaining to you how the graph would work. So in this case, end behaviors would usually go like this. Since if x goes infinite to the right, that means f of x goes infinite on the y-axis, since f of x explains on the y-axis. So you see how we did this. So what we did was, since x, it goes forever to the right, as we can explain with this arrow, you could tell that it goes upwards and it's going to continuously go up because of this arrow. As you can see, it just goes up in this direction forever and forever. And then since there's 2 lines within this, you wouldn't just make one for the positive side, you'd always make one for the left as well. And for the left, we usually interpret it as negative. So if x goes forever to the left, then f of x also goes forever up, because even if we go to the left, you can tell it goes upwards forever as well. Okay, so this is basically it on absolute value functions. I hope this video helped you just a little bit more. And if not, there are always other sources, but I'm pretty sure this one should have helped you pretty well. Okay, goodbye.